Welcome to today's lesson on Unit 5, continuing our work with systems of equations and inequalities. Today we will be discussing section 5.4, solving word problems using systems of equations. Our focus, our aim for today is to learn how are word problems solved using systems of equations techniques. In other words, how do we use substitution or elimination or even graphing to solve word problems? To get ourselves warmed up, I invite you to pause the video and see if you can answer this question. So I invite you to pause. I'm going to go over it now, assuming you have unpaused. So the correct person is Jennifer. Amanda has made a mistake. She is subtracting both of her equations. So she does 2x minus 2x correctly, but then she does negative y minus y. So negative y minus y should give us negative 2y, and then 6 minus 10 does give us negative 4. So it should be a negative 2y on the left. Divide both sides by negative 2. You get y equals positive 2. Plug that back in, you'd get x equals 4. I'm just jumping to the answer. 4, 2. And that is the solution that Jennifer had arrived at. Okay, so we got to be careful when we're adding and subtracting our equations. The first type of system we're going to learn to solve involves a question or a problem dealing with a break-even point. So what is a break-even point? Well, this has to do with when you are running a business and you're trying to make more money than you're spending. All right. So it has to do with running a business, how much money you're getting versus how much money you're spending to run the business. So a break-even point is the point after which you earn profit, or after which you earn money that you can keep. Okay, so the point after which you earn money you can keep. All right, in other words, it's the point at which the amount of money you've spent equals the amount of money made. So we can see this in the diagram. The red line represents our expenses, or how much money we're spending to run the business. So there's more practically, it really has to deal with if we're selling a specific item. So to make and sell an item is going to cost some money. We're going to have to spend some initial amount to get the business started. That's why the red line starts above 0. And then we're going to have to spend some money to maintain our selling our product. And once you start selling the product, after you sell one, for example, you make a certain amount of money, and then you keep going. You sell another one. You keep selling it. Eventually, you reach this point in the middle here. At this point, the amount of money you've made is equal to the amount of money you've spent to make your product, to make and sell your product. And then you continue to sell it. And ideally, over time, the amount of money you make will far exceed the amount of money you've spent. Okay, so the way this works for our purposes is that we're going to have one equation that represents the cost of making or selling our product, and the other which represents uh, the amount of money made. Okay? And we're going to set these two equations equal to each other to figure out at what point or how many items we have to sell for our business to break even. So we'll set the red y equal to the blue y. Okay. Last thing to note: the break even point. Once you reach it, the graph shows us in yellow. Once you go to the right of it, as you sell more items, you are going to make way more money than you spent. All right, so let's just see how this works. Example 1. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hat sells for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, so we're going to have one equation which represents the cost. So EQ1, equation 1, is going to be the cost of making the hats, of running the business. So making the hats is going to be $5.50 per hat. So we're going to say X is our number of hats, plus the $1,400 spent on advertising. So equation 1, this is our cost. In equation 2, this will be our income, the amount of money we're making. And that will be equal to, told us $12.50 per hat. When we sell it for $12.50, so 12.5x. All right. And now to solve this system, well, we could do elimination. We could do substitution. We could graph it. But what looks to be the obvious choice is just substitute y equals 12.5x. Substitute 12.5x in for the y up here. So we get 12.5x equals, let me fix that, 5.5x plus 1,400. Solve the equation, subtract 5.5x from both sides. You get 7x equals 1,400. Divide both sides by 7. X equals 200. So you might pause and ask yourself, what does this mean? What does x equal 200 mean? Well, so here's the answer. 200, it's how many hats that have to be sold to break even. So the owner has to sell 200 hats to make as much money as it has cost her to advertise and to produce the hats. Okay, so after finally selling 200 hats, she will have made back all the money she spent to get the material for the hats and on advertising to get her business name, her product out there. It's a lot of hats to sell just to make $0. But after 200 hats, the 201st hat, okay, she's making $12.50 on that, and keep going per hat made, or sold rather. All right, so let's look at another example. I invite you to pause and try on your own. I will jump into it so you can resume the video when you're ready. All right, a carpenter makes and sells rocking chairs. The material for each chair costs $22.50. The chairs sell for $75 each. If the carpenter spends $420 on advertising, how many chairs must she sell to break even? Okay, so we're going to have equation 1, EQ1, represent the cost. So the cost is going to equal 22.5, cost 22.5 per chair to make the chair, plus that initial $420 on advertising. So that was our cost. And then our income is going to be represented by equation 2. And the chairs sell for $75 each. So 75 times X represents how much money you make per chair. All right, now we have the same sort of system as before. We're going to substitute in. I see a y up here, and I see a y down here, which equals 75x. So I'm going to plug that in for y up here. I get 75x equals 22.5x plus 420. Subtract 22.5x from both sides. And we're going to get on the left 52.5 x 52.5x equals 420, and divide both sides by 52.5. Let's see what happens. And we get a nice whole number, x equals 8. Okay, so this carpenter must sell 8 chairs to break even. All right, so x equals 8. Okay, moving on to other kinds of systems of equations, word problems that we can solve. So, example 3. I suggest following along with this example, and then maybe trying example 4 on your own. So example 3, it says 2 groups of people order food at a restaurant. One group orders 4 hot dogs and 7 chicken wings for $34.50. The other group orders 8 hot dogs and 3 chicken wings for $30.50. Find the cost of each item. So if you're looking at this, you might almost be able to see we already have a system here. So let's do some let statements. That's what we want to start with to know what our variables represent. So let H equal number of hot dogs, and let C equal the number of chicken wings. All right. So we know in the first situation of what one group ordered, we have 4 hot dogs and 7 chicken wings is $34.50. So that's going to be 4H plus 7C equals 34.5. And the other group ordered 8 hot dogs and 3 chicken wings for $30.50. It's going to be 8H plus 3C equals 30.5. Okay. So you might be looking at this and thinking, nothing immediately jumps out to me. Should I substitute? Should I graph? Either way, some sort of work's going to have to be done. So my suggestion is to analyze the columns. So we have the H's are lined up, the C's are lined up, and the numbers are lined up. Well, what's interesting is that the 4H and the 8H, those are very close to one another. So we might be able to use multiplication to manipulate our first equation to turn that 4h into an 8h. So my suggestion is to multiply the first equation by 2. And when we do that, we will get 8h plus 14c equals 69. And then we're going to bring down our second equation, which is original. So the reason I multiplied by the 2 is so that we would have some things line up that can eliminate. In the bottom equation, I rewrite 8h plus 3c equals 30.5. And now we can subtract. Now we can subtract both equations. So the 8h minus 8h, that cancels. 14c minus 3c gives me 11c. And 69 minus 30.5 is going to give me 38.5. I'm just going to check, make sure I did multiplication right. I did. Okay. Okay, yes. So now we divide both sides by 11 to figure out the cost of chicken wings. So the cost of chicken wings is going to equal 38.5 divided by 11 is 3.5. So $3.50 per chicken wing. All right, but now I'm not done. Now I have to figure out the cost of hot dogs, so we know what to do. We're going to plug this back into one of our original equations, and we look for which one of the original two is going to be easier to plug that value, that c equals 3.5 into. And that's going to be the second one. 3 times 3.5 is going to be simpler than 7 times 3.5. So I'm going to rewrite it over here. So 8h, we don't know the hot dogs yet, plus 3. I'm plugging in c for c equals 3.5 for c in this equation. So 3.5 goes here, equals 30.5. And now I'm just going to evaluate and solve. So 8h plus 10.5 equals 30.5. Subtract 10.5 from both sides. 8h equals 20. Divide both sides by 8. And each hot dog costs $2.5. Okay. Oops. All right, so we have figured out the cost of each item. Chicken wings cost $3.50 per chicken wing, and hot dogs cost $2.50. I don't know who is buying 3 chicken wings, but I guess some people want that. All right, so moving on to, I think, our final example. Oh, we got 2 more. All right, so now I invite you to look at this one and see if you can figure out how example 4 works. Actually, shoot, example 4 is a little bit more like our break-even point questions. So let's do this one together. You'll be able to do example 5. Actually, you know what? Let's skip example 4. We already know how to do that kind of problem. You can go back and do it if you want. Let's go to example 5. I'd like you guys to pause and try to do this one on your own, and then resume when you're ready for the answer. So it says, the concession stand is selling hot dogs and hamburgers during a game. At halftime, they sold a total of 78 hot dogs and hamburgers. Okay, in total, 78 hot dogs and hamburgers. And brought in $105.50. How many of each item did they sell if hamburgers sold for $1.50 and hot dogs sold for $1.25. Ooh, okay, so this is a little bit different than what we've been discussing. Here's how it works. We want to figure out how many of each item. So we're going to say let x, we're going to have to use different variables here because hamburger and hot dog both start with h. So let x equal the number of hamburgers and y equal number of hot dogs. Okay, so this one's different. It gives us the total amount of everything sold and the total revenue it brought in, or how much money they made from selling it, and it tells us how much they were selling it for. So with this kind of problem, we're going to end up with two equations. One is going to represent the total amount or volume of the items, the total amount, and in this case, it's going to be x plus y. That's the total amount of hot dogs and hamburgers sold, and they told us 78. I kept track. They sold 78 hot dogs and hamburgers. The other equation is going to be the amount of money, or amount of money earned. So money earned, and we're going to represent this equation using what we know the cost of each item is. So hamburgers were 1.5 times x, and hot dogs or 1.25 per hot dog. So it's 1.25 times y. And in total, they told us they made $105.50. All right. So now we have to decide yet again what method we're going to use to solve this system of equations. So I'm going to suggest I think in this case, solving by elimination will be most convenient. And let's go ahead and eliminate x from the system. So what do I have to multiply my top equation by to remove x from the system? Well, I have to multiply the top by 1.5. All right, so then I'm going to get my new system over here, 1.5x plus 1.5y equals, what is 78 times 1.5? 117. And then the original second equation, which is right here, I'm going to rewrite 1.5x plus 1.25y equals 105.5. Yes. All right. Now we've got our columns lined up. And in fact, we're going to be able to cancel our x column. So 1.5 minus 1.5, that cancels. 1.5y minus 1.25y gives me 0.25y. And that equals 117 minus 105.5. And that equals 11.5. And then get y by itself, divide by 0.25. And y equals 46. So what does 46 represent in this case? Well, we said it's the number of hot dogs. So 46 hot dogs were sold. Now we got to go plug this into one of our equations to solve for x. Which one is it going to be easier to plug into? The top one. We plug it in up here. It's going to be very quick and simple to solve for x. So let's go ahead and do that. We have x plus, we're changing that y from the equation with 46, which we just learned, and equals 78. Subtract 46. X equals 32. So 32 hamburgers were sold. We said x was the number of hamburgers. and 46 hot dogs were sold. All right, that is going to do it for today. So, great job learning how to solve using systems of equations, where one equation represents one quantity, the other equation represents another, and we solve by substitution or elimination. Or you could graph. We didn't touch on graphing, but we know how to set up an equation in slope-intercept form and graph to see the intersection point. All right, really nice job, and stay tuned for the next one.